Children, in this video we will see some more points. Now one point in continuation with the previous video is that when we had acidic buffer, where we had the combination of weak acid, acetic acid, and its salt with strong base, sodium acetate, in equimolar amounts, we had seen the reaction. Now children, in that process of buffer action, we have concluded that the reserve acidity is due to acetic acid, where on adding base, pH was controlled. So on adding base, pH will be controlled by the acid. So the reserve acidity was due to acetic acid. And the reserve basicity means when you're putting acid and some base has to react with that, the basic part has to react with that. It was acetate ion, and which was definitely coming from your salt. That's why when I said acetate ions means it is clearly understood coming from your salt, sodium acetate. So one can say acetate ion, or one can say it is sodium acetate, working as a showing the reserve basicity, but it's better to call acetate ions. By saying acetate ions means clearly, indirectly, one has said sodium acetate. As I told earlier too, in the entire system, acetate ions were mainly from sodium acetate because it was a stronger electrolyte as compared to acetic acid, right? So this is there, you need to know. Reserve acidity was due to acetic acid and reserve basicity was due to acetate ions, which were coming from salt. Now, basic buffer. It is an equimolar mixture of weak base and its salt with strong acid. So weak base, say NH4OH, we all know very commonly, and its salt with strong acid, say HCl. So if NH4OH reacts with HCl, the salt form is NH4Cl. You can think of reaction NH4OH plus HCl, sorry, gives you NH4Cl plus H2O. So your salt is NH4Cl. So weak base and its salt with strong acid. Point clear. Then children, we will again see its buffer action, that how this combination works, shows its buffer action. So NH4OH breaks up into NH4 plus and OH minus. It's a weak base. Then we have stronger electrolyte NH4Cl, which breaks up into NH4 plus and Cl minus. Now children, again you know very well that in the presence of this strong electrolyte, this will ionize to a lesser extent, to some extent, right? Due to Coulomb effect. That phenomena is also there in the mind. Now, but that you keep aside right now. If you have put acid here, HCl from outside, small amount, so naturally H plus ions are entering your system. So they will affect the pH, definitely, and they should. But this, if this H plus is controlled by, checked by, attacked by the base. So base means not NH4 plus but OH minus here. It combines and gives you water, and you know water is weakly ionized, and you know I wrote OH minus ions from base. Hence it is weakly ionized and not much significant change in pH because water itself is weakly ionized. As we had seen in the last video also, pure water is non-electrolyte, just a polar covalent compound, but when some ions are present, it starts behaving as a weak electrolyte. So it is there. So you see children, reserve basicity was due to OH minus ion, which is coming from base. So I can say here, reserve basicity is due to base NH4OH. Here reserve basicity is due to NH4OH. Okay, NH4OH. Now add any OH. Suppose you're adding any OH now. What happens? NaOH breaks up into Na plus and OH minus. Now these OH minus ions will affect the pH, right? pH, they can alter, they can affect. Now if they react with something that their effect is minimized. So what happens? NH4 plus ions. Now children, NH4 plus ions are from here as well as here. We know very well, out of these two, NH4Cl will furnish larger number of NH4 plus ions than NH4OH. It's a stronger electrolyte as compared to this. So in your system, these NH4 ions which are seen from both of the compounds NH4OH and NH4Cl, but they are largely from NH4Cl. So these NH4 plus ions coming from salt, I wrote from salt, combined with these OH minus, which could have otherwise altered the pH, and they form again NH4OH, which we again know is a weakly ionized compound because it's a weak electrolyte. So that is there. Plus, in the presence of this NH4Cl, which is already present, it will ionize to a further lesser extent due to common ion effect. Hence, overall, pH undergoes change, no doubt, but very insignificant, very, very minute. Within practical limits, if you see, you can say almost no change or remains fairly constant or remains almost unaffected. Hence, no appreciable change in pH, whether you add acid or you add base. So you see, when you added base, it means you have to have that portion which finishes off the basic nature of this OH minus ion. So finally what happens, or which minimizes the effect of this OH minus ions. So NH4 plus ions coming from salt. So this was reserve basicity because HCl was being added up. This was due to your base NH4OH, and here reserve acidity because this base you have added. So now you have to have something which will minimize its basic character, which will minimize its basic change, which minimize the very, very character of this basic compound, the basic character of this OH minus ions will try to minimize the change in the pH due to these OH minus ions. So here the reserve acidity is due to NH4 plus ions, and these NH4 plus ions are coming from salt. So by saying NH4 plus ions means indirectly I am saying NH4Cl. Why did they not say NH4Cl precisely? Because children, it is weak base and it's salt with strong acid. It could have been any acid, it could have been ammonium sulfate, you never know. Right children? That's why they are not saying NH4Cl. They said NH4 plus ions, and when I said NH4 plus ions, it is very much obvious and understood coming from the salt. Right? Because NH4Cl is not the only strong electrolyte with ammonium ion. So we had the basic buffer was weak base and it's salt with strong acid. It could have been anything. Of course, most commonly we have this combination, but it could have been any salt with strong acid, ammonium sulfate, ammonium nitrate, whatnot. Right? But then we use this combination because it works very effectively. So here when I said reserve acidity is due to NH4 plus ions, means I said salt, and reserve basicity is due to NH4 plus, or one can say here reserve basicity is due to NH4Cl. If one says, you cannot deny this fact. Here reserve acidity is due to NH4Cl. Reserve acidity is due to NH4Cl, and reserve basicity is due to NH4OH. Or instead of saying NH4Cl, because it sounds very strange that I'm saying here reserve acidity is due to NH4Cl. You know, NH4Cl is a salt. That's why they just said NH4 plus ions. It can be anything, chloride or whatever, that's immaterial, because you see chloride was not playing any role anyway here. That's why they just said NH4 plus ions. By saying so, they said the salt is responsible for the reserve acidity and the base is responsible for reserve basicity. As in the previous case, for reserve acidity it was acetic acid, and for reserve basicity it was acetate ion, or one can even say sodium acetate. It is one and the same thing. But then again it sounds like basicity and sodium acetate. You know, it's a salt. That's why they said CH3CO minus ions. But this means nothing but sodium acetate, and this means nothing but ammonium chloride, or salt here, acetic acid, NH4OH base. For this it was for acidity, this was for basicity. Here this is for basicity, base, and this salt is for acidity. This way you have seen what is buffer solution, what are acid buffer, what are basic buffer, how do they work, how do they show their buffer action, if acid is added or if base is added, how pH is almost fairly constant, and what is responsible for reserve acidity or basicity. In all these cases, we have seen that. Even these points are asked in your competitions. So give time something in the evening, and do see it, give it time. For this video, we stop here. It is important, just need to see, even for competitions. And again, I can frame short questions also. So I hope points are clear, but do see once again in the evening and try to understand the concepts. This is all for this video.